Okay, let's go. We continue a series of interviews at the Gradle World Meeting. Today I invited Adam, who actually one of almost co-founders of Gradle, right?
Yes.
So when did you start with Gradle Build Tool and Gradle?
I started in about 2008. I was looking for a replacement for our Ant-based build system. Came across this new tool called Gradle. Started using it. Started sending in patches for improvements and fixes and so on. And Hans, the founder of Gradle, invited me to join as a committer, and then here we are, 15 years later, World Meeting.
Yeah, so quite a lot of changed since the days.
Absolutely.
What are you working on at Gradle?
So my main focus is on the build tool, the Gradle Build Tool, and in particular Declarative Gradle. So the initiative to improve sort of usability of Gradle for developers, and isolated projects, which is some improvements to Gradle to really make it scale really well for thousands and thousands of projects.
Yeah, definitely. Isolated projects is one of the most anticipated features. I don't recall how many likes we have on GitHub, but if you have a monorepo, if you have just a big project, I think it will be a game changer in terms of performance.
Yeah, absolutely. Yeah, and there's two aspects to it. There's like how long the performance of it, like how long it takes to do things like a sync in the IDE or run the tasks on the command line. But also, it has the potential to really enormously reduce the amount of memory that Gradle consumes while it's doing those things. So it's an exciting feature.
Yeah,
it's something we've wanted to do for many years. It sort of addresses some like fundamental issues with the Gradle configuration model, and when we can get those out of the way, then we can really take advantage of, so by adding these constraints and to the configuration model, that allows us then to do an enormous amount of performance improvements, and it's very exciting.
Definitely. My first encounter with Gradle was in 2011 or 2012. Actually, I started my career in electronics, in hardware. I was doing a lot of automation and running automation infrastructure with Jenkins and other tools. And basically one of our team was developing IDE that is based on Java. I believe it was Java 1.4 or something like that at that point. No, it was a little bit higher, but it was still 1.4 compatible. And actually Gradle was used to build multiple projects, and even then we already experienced some performance issues. I did some trick for parallelizing the build across multiple machines. Yeah. So of course at the time there was no Develocity, no distributed cache.
Yes, all kinds of stuff, yeah.
But still, classic NFS, etc. still worked as distributed local cache if you do it right. Yeah. So it was a long time ago, and basically since that there were many things that changed in Java ecosystem and many things that changed in Gradle. What are your key highlights of this period, and what are your learnings?
Ooh, it's a good question. I mean, there's a lot more to the ecosystem now. When we started Gradle, there was no microservices. There was no... basically, building your software meant compiling some classes and making a jar, and then you were done. Maybe you ran some unit tests. But now, the automation is far more ambitious and achieves a lot more. I mean, the automation goes all the way through to deployment, production, so the scope is a lot bigger for what the automation tools need to tackle out of the box. And that need to be easy because there's such common things that people do now that just were not a thing basically when we started. And then so that in terms of the ecosystem, and then you've got things like Kotlin have come along, things like Android have come along. These weren't things that existed, but not as a sort of widespreadly amongst the developer community at least. So these are things that Gradle has had to embrace and support and make better.
So basically supporting the whole ecosystem through massive evolution, through many changes.
Exactly.
It was automation infrastructure, space, tooling, frameworks.
Exactly. So it's just exploded. The scope of what a build system is, or what a software automation system is, has really expanded enormously. And we've tried to keep up with that and support those ecosystems as they emerged. I think from a Gradle perspective, so there's the scope, but there's also the scale as well. The software projects are just getting bigger, much bigger than we were when we started 15 years ago. The size of the teams, the scale of the amount of software that they produce has increased. It continues to increase. Every team is producing more software, more and more each year. So performance is a really important thing that we've had to really tackle. And certainly the early version, Gradle has had historically some scaling problems. And some of those are because of fundamental limitations in the configuration model, which is why with isolated projects we're kind of addressing some of those things so we can really scale well. But some of those are just sort of things, algorithmic problems in Gradle or whatever. So we've spent, I think for the last at least 5 years, I've really spent a lot of energy in improving the scalability of Gradle to be able to deal with many more projects and much bigger, software being produced. And we still have some way to go. But for me, those are the two things that really strike me as like what has evolved over those 15 years of Gradle.
Yeah. So one of Gradle evolutions to address scalability, etc., was actually Gradle Enterprise, then became Develocity last summer.
Mm-hmm.
So basically, it was one of the transition to address large-scale setups, right?
Absolutely, yeah, absolutely. So things like build cache and test distribution and predictive test selection and the acceleration. There's the acceleration features, but there's also just insights from build scans. Tells you a lot. You can discover pathologies in how your build automation's operating, and you can fix them. Sometimes they're very easy to fix once you know about them, and so just knowing is really valuable.
Right.
Yeah, and that's something definitely that's evolved, I guess, over the sort of lifetime of Gradle, is that this idea of getting deep insights into what's happening as an important tool for productivity and increasing developer productivity. You've got to measure, to optimize anything, you need to measure it first, and so now we can measure, so which means now we can be effective at making it more efficient and faster.
Okay. And what matters is actually everything that we face in the industry is not specific just to Gradle, right? Because even
Absolutely.
for Develocity, so I spent most of my career working with Maven, or with Golang, or with electronics design automation tools. Everywhere the problems are the same.
Absolutely.
And actually, this is actually, I saw quite excited transition when it was still Gradle Enterprise, because at some point it was Gradle Enterprise, but it was already supported Maven.
Right, yes.
And now it also supports SBT, Basel, and maybe soon there will be other tools.
Yes.
So, wearing my CDF ambassador hat, I have to ask, should we consider build tools becoming a commodity at this point? So basically, should we basically consider them as a kind of generic build tool that receives tasks, returns the results, or is it there is still a lot of logic and complexity inside?
There are enormous differences between build tools in how they think about software, how they describe software, how easy or not they are to configure and to understand and to use as a developer or as a productivity engineer. So they're not all the same. There are definitely differences between these different tools. Yeah.
Mhm. Yeah, that's for sure. The same time, maybe the interfaces get closer. So what we see in the ecosystem, there are more and more open standards appearing. So for example,
Right.
open telemetry,
Yeah.
open API,
Yeah.
open everything.
Yeah, yeah.
Yeah. And even in build tools ecosystem. So for example, one of our partners, Microsoft, they started the build server protocol, and actually there is a Gradle build server created by Microsoft, and actually this is a project they use in Visual Studio Code, and I guess it can be easily used outside for different setups. So, do you believe that even with a lot of complexity inside the tools, we could have a kind of universal interface?
Absolutely, yeah. I mean, you can abstract what a build tool does and how it operates, and so you can measure those things, and then you can take that data and send it out, and then you can use whatever tools you want to understand how well these things are working on. And yeah, so certainly you can see it certainly with Develocity. It's the same tooling that can, it's the same model that we're getting it's the same sort of information and telemetry we're getting out of each of the build tools.
Which is super cool, because in most companies, they're not using just one tool.
Absolutely.
So you have multiple tools, you contribute to multiple projects where you don't have much of a choice.
Yeah.
So having integrated system for all kinds of observability insights is essential.
Absolutely, yeah.
And all the data analytics too.
Absolutely.
So I'm quite excited to see what's happening in Develocity at that point,
Yeah.
including common Grafana dashboards,
Yeah,
etc.
yeah,
So
yeah, absolutely,
things
absolutely.
evolve quite well.
Yeah, so like having standard ways of getting the data in and then standard ways of getting the data out allows us and teams and tooling and humans and everyone to get these deep insights and be much more productive or make their tooling much more productive and their automation much more productive.
Definitely. So going back to Gradle itself, so for me, Gradle was always perceived as a kind of tool with steeper learning curve than other tools on the market.
Absolutely.
It's totally reasonable because I came from Jenkins space, which is a perfect automation server, but it means that you have configured that there are so many ways to do the things. And basically in Jenkins at some point we ended up creating a declarative pipeline that actually helped to unify definitions on the top level.
Yeah.
And when I saw that Gradle is doing declarative Gradle, of course it triggered a lot of memories. So could you
good ones, right?
Yeah, good ones. I mean, for me, Jenkins is still the most flexible tool, and for me it's must that as a user I can have all the flexibility, but for my users I want to offer simple build definitions.
Yeah, absolutely.
So whether declarative ones or simple configurations in YAML, so this is what I would like to offer to my developers, because they need to be productive.
Absolutely.
And their main job is working on their stuff, not on build definitions, etc.
Absolutely.
And basically, what is your vision for declarative Gradle? What are your key objectives?
Yeah, like it has it has that same spirit, right?
Okay.
Historically, I think the audience for Gradle has been the build engineer or the productivity engineer, the person on the team whose job it is to implement the automation, and less so for the developer who's actually just running the build. So, Declarative Gradle is a project to address that basically, and really focus on the developer who's using Gradle needs to understand it to some degree, or at least understand it enough to do their job. And their job isn't to do implement the automation. It's like, I want to build my software, I want to refactor it to add, split out some libraries, I want to, grab a new dependent version of a dependency, I want to add support for Compose, or I want to add support for Kotlin, or I want to add support for, I want to add functional tests now to my projects. Those sort of things, you should, as a developer, you should be able to do without understanding Gradle concepts, essentially. You should be able to do it in a way that you only need to understand domain concepts, like I have, a Java library, I'm producing a Java library or an Android application or, whatever, a piece of software, and I want to test it in this way, I want to publish it, I want to do this kind of static analysis on it.
Yeah.
Just let me express that in a way that I don't need to know about, source sets and tasks and plugins and Gradle concepts. So that's one aspect is comprehensibility. Make it really clear to the developers who don't care about the automation what's going on, what it is that the software is, and how all the relationships fit together. And the other aspect so that's one focus, is comprehensibility. The other is about tooling. So really first-class tooling for developers in the IDE. Well, not just in the IDE, but primarily in the IDE. That's definitely the initial focus, is give good ways for developers to sort of visualize what the build sort of structure is, what the software is, do those kind of common operations that we were just talking about before, upgrading a dependency, adding support for Kotlin, upgrading to a new version of the Android SDK or whatever. Yeah. These things are what developers want to be able to do easily, and so have the tooling really help them with that. So understanding what's there and making changes, typical kind of developer-facing changes. So there's those two aspects. Really, the idea is developer-first Gradle. Essentially, is really the goal, and those are two ways or two focus areas that we're using to. And
it's super exciting.
Yeah.
Because before you were still able to do that. So if you take combination of conventional plugins, of basically creating your own plugins for Gradle if needed, and Kotlin and all idiomatic Kotlin capabilities, you would be able to create all of that. So if you have an experienced build engineering team,
absolutely,
that is have enough expertise to build it, enough time and support from the company to keep maintaining that, you could probably build it.
Absolutely.
But now basically it becomes available more or less out of the box.
Absolutely, that's exactly right. So and teams do build these kinds of systems. People have built have built on top of Gradle ways of simpler ways for their developers to define software for their particular organization. So and what we want to do is basically distill all that goodness and bring it into Gradle so that it's available out of the box.
Yeah, and that's quite perfect because one of the problems. I also created quite a lot of frameworks based on Jenkins for various things. But the problem is every organization you join, you see maybe Jenkins or Gradle, but it's still different Jenkins or Gradle, and then your onboarding time is quite high.
Yes, absolutely.
So basically offering declarative Gradle not only helps for that, but also helps to transition between different projects, companies, and actually it's really good for productivity and for onboarding of new users.
Absolutely, no, that's exactly right. So because Gradle hasn't offered that out of the box, teams do go and invent their own way, and that might be extremely productive. And so some of them are extremely productive for their developers. But that person who's learned that thing then goes to another project. It's it's completely different. So I think that's exactly right. So by having Gradle define some things that you can extend, that helps with that. It helps with the onboarding and moving between projects, which again is part of developer productivity. It's an important part of when you join a project, you need to be able to get up to speed quickly and understand what's going on. And so the tooling and the comprehensibility that we're working on, I think, will really help with that kind of thing. You can take a project, you can load it up in your IDE, you can immediately understand what it is that's happening.
Totally supported. I'm a huge proponent of open source and also inner source inside organizations. So such tools, such basically frameworks, etc. They help a lot. And by unifying them, by providing documentation, proper IDE support, etc., we actually save a lot of time for your build infrastructure teams or whatever you call them, maybe developer productivity teams in your companies, and basically that definitely should reduce time for onboarding new projects and also for developing one from scratch.
Absolutely.
With Gradle being adopted more and more, especially in areas like mobile development with Android, in modern frameworks like Spring, etc., it's actually quite important to support this development.
Absolutely, yes.
Yeah. And what are the next steps for Declarative Gradle?
So it's still we're working on some prototypes, sort of alphas. I guess I would call them. Mm-hmm. What we want to do is basically get feedback from people, early mm-hmm. feedback from people, whoever is interested. On the does the direction we've chosen, does the implementation of this prototype, does it actually hit those, does it actually succeed at those goals? And it's very hard. We don't know. We're working on it, right? We understand it, of course. So we need to get that. It's critical for the success of that is to get that feedback from people. So we want to produce a series of prototypes, alphas that and have people try them out, give us feedback.
A lot of prototypes, they are already available. So on Gradle/Declarative Gradle repository, there is a bunch of prototypes, including Kotlin projects, Java libraries, Android applications, etc. So there is also a quite good set of prototypes that are rather visionary, etc. So this point there is a lot of opportunities for feedback.
Absolutely.
Thanks a lot for making it possible. So for me, one of major milestones for the next is when a user will be able to try it out. What would be your expectation?
I mean, it depends a bit about what we mean by try out.
Let's say for their project, so I want to develop my own mobile application.
Yeah.
Seriously? I would like to start from Declarative right away. I think that'll be a few more milestones before we get to that point. So this kind of first milestone that we're working on is it's really intended for people to sort of look at the prototypes and play around with the prototypes and just get a feel for this. They are intentionally missing some important things that you would need to actually use them. So we'll then do some milestones after that to add in. Like an example would be testing. So we've intentionally left testing out just to be able to go faster and try some things out. But you can't, or at least you shouldn't, do a real project that doesn't have any testing. That would be definitely
not a good idea.
Well, it's definitely a matter of stabilization. I thought prototypes is totally fine. And what I also like, that actually it's still, even now, it's not a project in isolation because there is a lot of partners involved.
Absolutely,
So Google, JetBrains, a bunch of select end users, etc. We have really big companies using Gradle, so they can already try out and get a perception of some things.
Yeah, absolutely.
So hopefully by the time it sees the light as a kind of preview, etc., it will be already battle tested.
To some degree. Yeah, absolutely. Yeah, absolutely.
Well, I'm definitely willing to do some dog fooding on my own.
Yeah.
So looking forward to that.
Yeah. Well, me too. I think it's a very exciting project and something we've wanted to do for a long time. So really excited to see where it goes.
So one of our next steps is actually Kotlinconf. We will have a presentation by Paul Murdoch and Sterling Green, who they will present basically Declarative Gradle and what we are doing there. Also join us at the Gradle booth. Hopefully you'll have some demos to show. I'm already planning something. Speaking of the Android app, by the way. And it will be quite a good discussion there, I hope. And then basically other conference like a community overcode in June, etc. So we will be using these events also to validate feedback, to talk to open source projects. So let's say if you're a maintainer of a project using Gradle and want to make it simplified for users, especially if you maintain a framework library, talk to us. So I think it will be a good opportunity, and soon we will be looking for basically pilot adopters in the community, right?
Absolutely.
So I think it's a great opportunity to talk.
Absolutely.
Okay. So stay tuned for more news, and thanks a lot, Adam, for sharing insights with us. Anything else you would like to share with the audience?
Not particularly. Keep an eye out for the prototypes and give us some feedback. And same with isolated projects as well. It's a similar situation where we want to get feedback on people on the effect that it has, and if there's any the blockers that they might have in migrating or and so on. So
okay. That's really cool. And again, thanks a lot for your time.
Thank you.
Looking forward to the more updates in the newsletter, on other channels, and of course there is Declarative Gradle channel on the Gradle community Slack. So if you have any questions, feedback, join this channel, and there are already quite interesting and sometimes even heated discussions about particular topics. So when you basically develop a new language, definitely there are many people with strong opinions. Absolutely. So it's a great time to join this discussion and contribute. So thanks, Adam, and thanks everyone for watching. See you soon.